I'm Anil Kumar. This video is on vectors in 3D space. I hope all the students who want to understand 3D space, for them, this could be a very important video to watch. We have 15 multiple choice questions followed by 5 descriptive, communication and thinking questions. I'm going to begin with the last 5 questions so that I give you the concept, and once you know this concept, then you could easily do those 15 multiple choice questions. Well, most of those 15 multiple choice questions will also involve concepts of 2D and whatever you have learned so far, so that we kind of review what we have learned and move forward. That's the whole idea. So let's look into these questions first. Question number 16 is, describe the octant in which each point is located in 3D grid. Now, octant, like in Cartesian plane, we have 4 quadrants. In 3D space, we have 8 octants, right? So we'll talk about them. Question 17 is, describe the location of each point on 3D grid. So these are the ordered triplets, and we will see how to locate them on 3D grid. Question 18 is, sketch the position vector 2i 3j plus 4k. Is kind of similar to 17. Question 19 is, determine the angle that the vector OP equals to 1, 2, 3 makes with each coordinate axis. We call them direction cosines. So when we say vector OP makes with coordinate axis, these are called direction cosines. Let me write down the word direction cosines here. Question number 20 is, right triangle ABC has vertices A as K77, B 165 and C minus 298. Find all possible values of K. Now that will give you a review of what all you have learned so far. So the idea is not only to get into a new concept, but also to review what we have learned so far. So I hope you enjoy this journey of learning about 3D space and also review what we did earlier, correct? So let's discuss these communication questions one by one. Question number 16 is, describe the octant in which each point is located in the 3D grid. So let me begin with sketching the 3D plane here. So here we have X, Y and Z axis. All of them are orthogonal to one another, right? So X, Y and Z. Right angles. So you can see this like a corner of your room, right? That is how it should look like. So when you draw it, this is how you should show that they are at right angles. So I hope that makes sense, right? Now let's see how to describe this space, right? This is our 3D space. To describe this space, we will be using few terms, which is, we'll say front and back, right? So we have terms like front and back, right? And then we will also say front and back, and we say left or right. So for each, we'll say left or right. And then once we know left or right, we say top and bottom, right? So let me write T and B here. Top and bottom for each, right? So top and bottom, top and bottom. So that gives you 8 locations, correct? So that gives you the 8 locations. So for describing where each point is, we'll say whether it is in front or in back, and then whether it's on the left side or on the right side. And once we know that, then we say when it is top or bottom. Is it okay? So that gives you 8 different options, correct? So I hope that makes sense. Now, let's take a point and then figure out where it is located. 2, 3, 4. So when I say 2, 3, 4, 2 is along the x-axis. Let's say this is 1, this is 2. So we move 2 units in this direction. Then 3 units along y. So we go 1, 2, 3. Let's say this is 3 units along the y. And 4 is along the z-axis. So equally spaced 4 units, correct? So that gives you the position. And we'll say our vector this is from here to there. Correct? So let me call this as A. Then I'll put this point as A. And this will be at O. So the vector will be named as OA. So that is how you actually get a particular vector in R3. Correct? I hope that makes sense, right? Now if you have to complete this box here, how will you do it? First make your base. So you have kind of a, you see a box here, rectangular, right? Complete this box. Of course, this will be a solid sign. This you could see, right? So, okay. So all lines should be parallel, kind of. Okay. This is not all that good. Anyway. So that is how it is. Now, where do you think this box is placed? That gives you the octant. So I hope the concept is clear now, right? So we can see that this box, if you see from this coordinate axis, let's say corner of your room, you will see it is on the right side and in front, correct? So we can say front, right, and top or bottom over. Imagine this is your tabletop, right? It's on top. So we'll describe this location as front, right, and top. Do you agree with me? Do you understand? That is how you're going to describe. Now let's take the other two and do it fast. B, minus 1, 2, 3. Minus means you have to go there, that side. Do you see that? So you get minus 1 unit. 2 means right and 3 means again above. So you're on top, right? So this is top position. And that gives you where you are. So you're going behind, back. So in this case is back, right? Still you're on the right side and on top. So basically you see that the y coordinate gives you left and right. X coordinate gives you front and back. And z coordinate gives you top and bottom. So if I have a coordinate which we call ordered triplet, so these are called ordered triplets. For many of my students, this could be their first exercise on 3D space, right? So I'm explaining each and every term. Okay, so what we see here is we are going back. So this means x, right? So we say front or back. We say back, okay. Now, if you look into the y, then we decide left or right. So negative means left and positive means top. Does it make sense to you? Correct? So if I have a point which is minus 3, minus 2, minus 4, for example, then it is, you have to figure this out. So this means you are in the back side, and this means you are on the left side, and that means you're at the bottom. Do you get the idea? That is how you describe octants. And how many octants do we have? We have 8 octants. And that's the combination. Perfect. So let's move on and now take question number 17. Question number 17 is describe the location of each point on 3D grid. So it is exactly what we did earlier in question number 17, right? So what we will do now here is quickly sketch these points. So when I say 0, 0, 4, it really means you don't move along x-axis. You don't move along the y-axis. However, you move along the z-axis, correct? So where are you? How will you describe this position? So we have to understand describing these positions so that we can communicate better for all vectors in 3D space, right? So you see this point is only on the z-axis, right? So we'll say it is on positive z-axis. That is how you're going to describe it. The second point here is b, which is -1 to 0. So -1 means you're going backside, right? -1. 2 means you're here, but you are on the xy plane. You're not moving up. Is that okay? So how are you going to describe this? So this is on the back side on xy plane. Does make sense to you, right? You could say right also, right? Back right. Perfect. Point C is 3, 1, -2. So 3 really means you are on front, correct? So that gives you front. 1 means on the right, and -2 gives you bottom. Correct? So you should locate this point. 3, 1, 2, 3. 1 means you go 1 unit to this side, and -2 means go down. Is it okay? So that gives you the position. So that is my vector position, and this is the description, right? So I hope the concept is absolutely clear. So let's move on. Question number 18. Sketch the position vector, right? So let's try to sketch this now. Just as we did previous two, we'll do this again. You can actually pause the video now, answer the question, that means sketch the vector, and then look into my suggestions. So 2, 3, that means we'll go 1, 2 units, and then 3 units, 1, 2, 3, and then 4 units. Perfect. So that is the position vector. So I can always sketch my position vector like this. So that is how you have to sketch. I'm not making a box this time, but you can always make a box, right? So that is how you make a box, correct? To really understand how it should look like, correct? That is it. Do you get it? So I hope this concept is very clear. It is a new concept for many of my students, and so I'm taking time with these few examples. Question number 19. Determine the angle that the vector OP equals to 1, 2, 3 makes with each of the coordinate axes. Now we call these angles as direction cosines. So let me introduce you to this term, direction cosines. Now normally they are referred to as angle alpha, beta, and gamma. Alpha is with x-axis, beta is with y-axis, and gamma is with z-axis, right? So let me sketch this and explain you a bit, and then we'll move forward and answer this question. So when I say that the points are 1, 2, and 3, that means along the x-axis we'll go 1 unit, along the y-axis we'll go 2 units, and along the z-axis positive 3 units. So we get to a point. So that becomes our position vector OP, right? So from tail at origin and head at the final position gives you the vector. Let me complete this box as we did in some of our examples earlier. Right? So that is how we are going to complete this box. Okay. So when we talk about the angles, so we are saying the angle which this vector OP makes with the x-axis, so this is your x-axis, that is y, and this is z, is basically this angle. So we call this angle as alpha. With y-axis, that is the angle, we call it beta, and this is the angle with the z-axis, we call it gamma. Correct? So that is how we know the angles, correct? To find each angle, we have to find the dot product. We can use the dot product to find the angle, correct? Let's see how to do it. So the question is, determine the angles that this vector makes with each of the coordinate axes. So let's first find alpha, right? That means we are trying to find alpha. That means we have to look for projection of OP on x-axis. That is kind of concept. Do you understand? You could easily see if I am looking at y-axis, beta is the angle, so cos of that, correct, will give you the answer. So let's see projection of OP on the x-axis. So to calculate the angle, we basically find the dot product of OP with the unit vector I along the x-axis. Okay, so that gives you the magnitude of OP times the magnitude of vector I, which is the unit vector, times cos alpha. Since alpha is the angle between these two, right? So we can rearrange and write what cos alpha is. So cos alpha is the dot product of our vector with unit vector I divided by the magnitude of our vector OP times unit vector magnitude. Correct? So the vector here is 1, 2, 3. So we'll write 1, 2, 3. Dot product I unit vector is 1, 0, 0. Correct? And magnitude here will be square of 1 plus square of 2 plus square of 3 square root times 1. So let's figure this out. So it is just 1 over. This is 1 plus, well, let me write down, 1 plus 4 plus 9. So it is 1 over square root of 14. And therefore, we get cos alpha is this much. So alpha is equals to cos inverse of 1 over 14. So let's find out how much it is. I mean square root. Okay, so we have cos inverse of 1 divided by square root of 14, and that is equal to 74 point, I can say 5, right? So let's write down this as 74.5 degrees. So that becomes your direction cosine with respect to x-axis. Does make sense to you, correct? So you have to do this operation for all the angles to get the result. As you can see, ultimately we had the magnitude of OP in the denominator and the direction along the x-axis in the numerator, correct? So that gives you an idea. That is, we could find the other angles by using the formula that cos beta should be equal to 2 over square root 14, right? And from here we can find what beta is, and cos gamma should be equal to 3 over square root of 14, right? So I hope from here you can also derive the general formula, right? So beta is cos inverse of 2 over square root 14, and gamma is cos inverse of 3 over square root of 14, correct? So let's use the calculator again to find our result. So I just change the value 1 to 2 and 3 and then calculate, correct? So our answer is equal to 57.688. So we get this as 57.7, right? And here we have 3. So I've taken values which are easy to calculate. We are working more to understand the concept, right? So this angle is 36.7. We rounded them all to 1 decimal place. Does it make sense to you, right? So that is how you could find the direction cosines for any given vector, correct? So in general, we can write down the formula as, I'll write down for alpha, you can replace this with all others and then say square root of a square plus b square plus c square if your vector OP is ABC. Does make sense to you, right? So if it is beta, A will be replaced by B. If it is gamma, A will be replaced by C, correct? Now let's look into question number 20, which is the last of this communication series. Here is question number 20, which has been my assignment question for many students, and I have actually never seen a complete answer for this question. So let me discuss this at length. Question number 20 is, Right triangle ABC has vertices A, K77, B, 165, and C, -2, 9, 8. Find all possible values of K. I'd like you to pause the video, answer this question, and then look into my suggestions. Now, this is also the last question of my series on communication and thinking questions, right? So let's figure out what are these sides, right? So let me say, I want to write K first. So I'm saying that my sides are BA. So BA will be equal to K minus 1. So I'm saying K minus 1. And then 7 minus 6 is 1. And 7 minus 5 is 2. So that is BA. Now, what is CB? So CB is going to be C to B. So we have 1 minus 2, which becomes plus 3. 6 minus this is minus 3. And 5 minus this is again minus 3. Okay. And now let's say CA is what? CA is K minus 2 is K plus 2 minus minus. And 7 minus 9 is minus 2. 7 minus 8 is minus 1. Correct? So these are the sides of my triangle. Now, we are saying that it is a right triangle. Important thing is we have not specified A, B, or C. Which one of these is actually at 90 degrees, right? Now that is very critical to understand. So since that is open, so in such questions, we have to keep this option open. Do you see that? So we have three possible situations. So we have three possible situations. Let me just make three different triangles here. I hope you get the concept, right? So what are these situations? We could have right angles at A, we could have right angles at B, we could have right angle at C. These are the three situations, correct? So we can say this is A, this is B, or this is C, which is at right angles. And accordingly, we can actually call other sides as, so C, whatever, right? So just write them as A, B, C. Does it make sense to you? So basically, we have three different cases to work with, and each case will result into different value of K. Now, when you're working with the case 1, in that case, BA dot this side, which I'm saying A to C or CA, whatever, right? It should be equal to 0. Does it make sense to you? Here, B is right there at the right angles. So we say BA dot CB equals to 0. Here C is there. So C is common to these two. CB dot CA equals to 0. So these are three different scenarios. Let's begin with BA dot CA first. BA is K minus 1, 1 and 2 dot CA is K plus 2 minus 2 minus 1 equals to 0. So when you multiply, you get, let me write, we'll do it in two steps. K plus 2. And then we have 1 times minus 2s minus 2, 2 times minus 2s minus 2 equals to 0. So K square plus 2K minus K minus 2, and this is minus 4 equals to 0. So we have K square plus K minus 6 equals to 0. You could factor this, correct? Product of minus 6, sum of plus 1. So that means positive 3 times K minus 2 equals to 0. So that gives you K equals to minus 3 or K equals to plus 2, correct? So that becomes our case number 1. Now let's do the second case, which is BA dot CB is 0. So BA is K minus 1, 1 and 2 dot CB is 3 minus 3 minus 3 equals to 0. So that means 3 times this is 3K minus 3 minus 3, and 2 times this is minus 6 equals to 0. So we have 3K equals to minus 6 that comes to that side as plus 12. So k equals to 12 over 3. So we get k equals to 4, correct? Okay, so let's move on and do the third case, which is CB, CA. CB is 3 minus 3 minus 3 dot CA, which is k plus 2 minus 2 minus 1 equals to 0, correct? So let's multiply. So 3 times k plus 6, minus and minus makes it plus 6, minus and minus makes it plus 3 equals to 0. So we have 3k, 6, 6, 12 plus 3, 15 equals to 0. 3k equals to minus 15, or k equals to minus 15 by 3. So we get k equals to minus 5. Correct? So depending on each scenario, these are possible values of k, and so we write down our answer as k is equals to minus 3. It could be 2, it could be 4, it could be minus 5. So these are all the solutions for the given question. Do you get it? Right? So when we are working in this exercise, we have to really look for all possible solutions. It has a meaning, right? So find all possible values of k. That is how it should be done. Perfect. So now we have discussed all these communication questions. Let's begin with our multiple choice questions, and we'll rush through them fast since most of the concepts are now known to you, right? So I'd like you to get ready with your calculators and answer these questions one by one. Question number 1 is, a vector makes 42 degrees with x-axis, 49 degrees with y-axis. What angle does it make with z-axis? So we're talking about direction cosines. 4 values are given to you. Well, the concept which you should know here to answer the question is that cos square alpha plus cos square beta plus cos square gamma is always equal to 1. That is very important, right? So these are your direction cosines and their magnitude. If you kind of get like this, if you have a unit vector in the direction of your vector, you can straight away read their values. Okay. Now since we know alpha and beta, we can find what gamma is. So we have cos square gamma as equal to 1 minus cos square alpha minus cos square beta. Is it okay? So that gives you 1 minus cos square 42 degrees minus cos square 79 degrees. Is it okay? So we'll get the value of cos square gamma. So let's calculate this value. So it is 1 minus cos of the angle, which is 42 degrees, and we'll square this, minus cos of the angle, which is 79 degrees, and we'll square this. So what we get here is equal to 0.41132, right? So what is cos alpha? So cos gamma, I mean, is square root of this, which is 0.41132. So we'll do square root of this. Square root of our answer is equal to 0.641, and gamma will be equals to cos inverse of 0.641, correct? So we'll do cos inverse of our answer, and that is equal to 50.10 degrees, correct? So that is how it has to be done. So I hope the concept is absolutely clear. Option B is the right option. So if you know it, you just can do it in much lesser time. Question number 2. The unit vector ijk, normally we could write like this, are A, B, C, D, 4 choices, linearly dependent and can span in R3, linearly dependent and cannot span in R3, linearly independent and can span in R3, linearly independent and cannot span in R3. Now here we have critical words: linearly dependent, linearly independent, and span. You need to understand all these three terms. Now what are IJKs? IJKs are unit vectors in direction of x, y, and z, right? So these are IJK vectors. You can see that they are not in the same plane. They are not coplanar, right? They are actually at right angles to one another, as you can see here. They are not coplanar. And what you can do here is you can write any vector as a combination of these three. That means they can span. So they can span. Span basically means that any vector in this space could be written as a combination of IJK. That is, if this is my vector u, I could always write u as a times I plus b times j. These are unit vectors, plus c times k. Do you see that? I could write all this. Now you'll also notice that when you write a vector like this, can it be 0? Well, 0 vector is only possible if A, B, C, if A equals to B, E equals to C, all are 0. Do you see that? Only then it is 0, otherwise not. Since that is the condition, that means they are independent vectors, right? So they are independent vectors. So the correct option is linearly independent and can span in R3. Option C is the right option. Correct? Now let's look into question number 3. Find the perimeter of a triangle ABC whose coordinates are: A is 2, 4, 1, B is -1, 2, 2, C is 7, 0, -4. Perimeter means length of each side has to be summed up. So let's find what is AB. AB will be this minus this, which is -3. 2 minus 4 is -2. 2 minus 1 is 1. And AC is 7 minus 2 is 5. 0 minus 4 is -4. -4 minus 1 is -5. And now we can write what BC is, correct? BC is 7 minus 1 is 8. 0 minus 2 is -2. -4 minus 2 is -6. We are interested in finding their magnitudes. So magnitude of AB will be square of these, 9 plus 4 plus 1, which is square root of 14. As far as the magnitude of AC is concerned, it will be square root of 25 plus 16 plus 25, which is square root of 50 plus 16, that means 66. And magnitude of BC is going to be square root of 64 plus 4 plus 36. Now sometimes you may not be allowed a calculator, so then this calculation really helps. So 4 plus 36 is 40, so we get 104. Right? Anyway, you have to use calculator to add them up. So perimeter is equal to sum of all this, which is square root of 14 plus square root of 66 plus square root of 104. And that is, let's figure it out. So we have square root of 14 plus square root of 66 plus square root of 104 equals to 22.06, right? The closest option is 22.1. That works for us. It rounds to 22.1. Correct? Question number 4. Vector U, which is ABC, has magnitude of 6 and same direction as the vector 2, 3, -1. Find the value of B. So we have to find the value of B. So that is the direction given to us. Vector U is ABC and has a magnitude of 6. So what we can do is that we can find unit vector in this direction. So let's say our direction vector is 2, 3, minus 1. So the unit vector in the direction will be 2, 3, minus 1 divided by the magnitude of vector d, right? Which is 2, 3, minus 1 divided by square root of 2 square, which is 4, plus 9 plus 1. So which is square root of 14, right? So that means the vector u will be, that is the unit vector, correct? Will be 6 times the unit vector d, right? So which will be 6 times 2, 3, minus 1 over square root of 14. We are interested in finding the value of vector b, which is this vector, correct? So the value will be 6 times 3. So vector b will, I should not say vector b. The direction b, this will be 3 times 6, 18 divided by square root of 14, correct? You could go one more step here. Say this could be 1 over square root 14 times 12, 18 minus 6. Is it okay? So this is what we need to calculate. So it is 18 divided by square root of 14, which is equal to, in decimals, 4.81. So the option C, 4.8, is the correct option. Correct? Question number 5 is, if vector A is I plus 3j plus 2k and B is 2i plus 4j plus k, find the unit vector perpendicular to both. Now unit vector perpendicular to both means we are looking forward for cross product of these two, correct? And the vectors are, let me write their parameters, 1, 3, 2 cross with 2 minus 4, 1, correct? So that is what we'll find, and then we'll divide by its magnitude to get the unit vector. So to do this, there are different methods. So one which we normally use is write this as 3, 2, 1, 3. Then start with the center value, that is, right? 2 minus 4. And when you multiply these are positive values, correct? So it is I times 3, minus and minus makes it plus 8, plus j times 2 times 2 is 4, minus 1, plus k times minus 4, minus 6. So these are the unit vectors, correct? And what we get here is 11i plus 3j and minus 10k. So that becomes perpendicular to both. We want unit vectors, so we are going to divide this by, so this is a cross b. Now let's divide this by the magnitude of a cross b. Is it okay? To get the unit vector, so which is going to be square root of 11 square plus 3 square plus minus 10 square, correct? So that is what the answer will be. So 11, 3 minus 10, we have a couple of them like this. Let's find this magnitude. So we could actually match. These are two positive, only 10 is negative. So the option is C for us, correct? So this is definitely some number. So it should be 230. Is it okay? So let's move on and do the next question, which is question number 6. If vector A is 2, minus 3, 7 and B is minus 1, 6, 5, we need to find 2A minus 3B. Now, magnitude of 2a minus 3b. So let's find what is 2a minus 3b. So we have to add twice, 2 minus 3, 7, minus 3 times, vector b is minus 1, 6, 5. That gives us 4, and that becomes plus 3, right? Minus 6, and that becomes minus 18, 14, minus 15, correct? And that is 7 minus, so we have 24, and this is minus 1, and its magnitude will be equals to, so magnitude of 2a minus 3b is equal to square root of 7 square plus minus 24 square plus minus 1 square, correct? So that becomes the value. So we are working with square root of 7 square plus 24 square, all will be positive, plus 1, which is equal to square root of 626, which is equal to 25.01. So option D is the right option, correct? Here is question number 7. The vector 1, 0, 1, 1, 1, 1 and 1, 0, minus 1 are coplanar, true or false? Now to show that they are coplanar, we can find scalar triple product, correct? So that is to say that we could do 1, 0, 1 cross with 1, 1, 1 and then we can dot it with 1, 0, minus 1, correct? So if the value is 0, that means they are coplanar. If not, it is not coplanar, correct? So that is how we could do it. Now scalar triple product, this is also called scalar triple product. Is it okay? Okay. So another way to do this is in this form, we could just write this as 1, 0, 1, 1, 1, 1. 1, 0, minus 1, right? And then figure out its value. So it could be 1 times this product, which is minus 1, minus 0. 0 times anything will give me 0, plus 1 time 1, that is 0, minus 1, correct? And this is what we get here is 1 times minus 1 is minus 1. This is plus 0. And here 1 times minus 1 is minus 1. So what you get here is minus 2. Since it is not equal to 0, that means they are not coplanar, right? So the vectors this is a coplanar is false. Is it okay? So they are not coplanar. Correct. So let's move on. The next question for us is question number 8. The 3 coordinate planes divide 3D shapes into how many regions, right? So as we learned in our communication thinking problems, so that is your 3D space. So we divide it in front and back, left, right, and top and bottom, right? Top and bottom. Combination of these, right? Combination of these. So 2 to the power of 3, 8 combinations are there. We have 2 to the power of 3 combinations, which are 8 in all. And we also refer to this as octants. So there are 8 octants in which we describe our point or position in 3D. Question number 9. The distance between the points minus 8m and m9 is 13. What is the value of m? 4 choices are given to us. So distance d is equal to square root of m minus and minus becomes plus 8 square plus 9 minus m whole square. And this distance should be 13, correct? So we can square both sides. So we get m plus 8 whole square plus 9 minus m whole square equals to 13 square, correct? So that gives us m square plus twice ab, which is 16m, plus square of 8, which is 64, plus 9 square is 81. Twice of these with a negative sign, 2, 9, 18 m, and this gives me plus m square, and that is 169, correct? So combining these, we get m square plus m square is 2m square. 16m minus 18m is minus 2m. And let's add them up. We have 64 plus 81. Take away 169 is minus 24 equals to 0. So I brought it on the left side, correct? So we have a quadratic equation. Let me take 2 common. So we get m square minus m minus 12 equals to 0. Now we are looking for a product of 12 minus sum of this. So that could be m, so bigger number is negative, times m plus 3 equals to 0. So that gives us the values as 4 and minus 3, correct? So plus 4 minus 3 is the correct option. So option A is the right option. Next question here is question number 10. The unit vectors A and B make an angle of 60 degrees with each other. Find the magnitude of 2A plus 3B. So let's also find what is A dot B equals to this, right? They are unit vectors. That means their magnitude is 1, correct? So that is A dot B, angle is theta, cos 60 degrees, correct? Now, since their magnitude is 1, they are unit vectors. So we could say 1 times cos of 60 is half, correct? So A dot B is half. To find the magnitude, what should we do? Well, the square of the magnitude of 2A plus 3B is, we could do their dot product. That gives you the square, right? So that is 2A plus 3B dot 2A plus 3B. I have taken this question mainly because in the previous portion, many students could not get this answer. So I have included few from R2. So now when you do dot product, we get 4 times magnitude of A square, right? So that, then you get plus 6 A dot B, right? So it's good practice to when you write them with their vector notation. So plus 3 times 2, 6 A dot B. And then you get plus 9 B square magnitude. Is that okay? Now since they are unit vectors, these values are 1. So we get 4 plus 6 times A dot B is half. So it is half plus 6 times half plus 9. Correct? So that is your square of the magnitude. Remember to square root it. So we get 4 plus 9 is 13. 13 plus 6 is 19, correct? So this 12 half is 6. So we get 19. And therefore, the magnitude of 2A plus 3B should be equal to square root of 19. Is that okay? So square root of 19 is between 4. 4 square is 4 and 5. Is it okay? So the only option is option C for us. So that's how we can do it. Question number 11. A triangle has vertices A, B, and C. The area of the triangle is, since we have to find area, we'll do cross product. So let's figure out what is AB first. So AB is 3 minus, which is 4. Minus 1 minus 3 is minus 4. 1 minus 4 is minus 3, right? So let's find what is AC. So you can do any two sides. So AC, 5 minus 1 is 6. 1 minus this is minus 2. 1 minus 4 is minus 3. Okay. So let's do AB cross AC. Area will be half of this since it is a triangle. So we do half of this cross product, right? So to calculate the cross product, let me rewrite them starting with the center value. Minus 4. And then we write minus 3, 4, minus 4. For this, minus 2, minus 3, 6, minus 2, correct? So let's calculate the area here. It is cross product. So 4 minus 3 is 12. So I times, this is positive 12, minus of this, which is minus 6, plus j times 3, 6 is minus 18, negative of this makes it plus 12, and plus k times 4 times 2 is minus 8, and that becomes positive 6 times 4 is 24, correct? So that gives us, let's do this in the space. So we'll do it here. So we get I times 12 minus 6 is 6, and here we get minus 6j. Okay, and here we get 24 minus, so we get plus 16, right? 16k. Correct? So that is the value. Magnitude will be, let me just confirm, 24 minus 8 is 16, and we'll do square of this. So magnitude will be square of this and then square root. So square root of 6 square plus 6 square plus 16 square is the magnitude, correct? So we do square root of 36 plus 36 plus 16 square, which is in decimal values 18.11, correct? So we have this as half of the cross product magnitude. I should have written here. This is all we did for magnitude. This is AB cross AC, correct? So we found its magnitude here times half of 18, right? So that is 9.1 is the correct option. Question number 12. The vector A has magnitude of 7. The x component is 2 and y component is twice z. So basically we could write vector A as equals to, let's say, x, y, and z. We are saying that the magnitude of vector A is 7. X component is 2. That means x component is 2. Y component is twice z. So it is 2 times z, and then we have z here. Find the y component. So we have to find the y component. That's the question, correct? So from here you can say 7 is equal to square root of these squares, 2 square plus 2z square plus z square, square root, or we can say 7 square is equal to 4 plus 4z square plus z square, which is 49, equals to 4 plus 5z square, correct? Or 49 minus 4 equals to 5z square, which is 45, correct? 45. And therefore, this implies that z square equals to 45 over 5, which is 9, correct? So z is square root of 9. You could do plus and minus. Anyway, what we get here is 3. So 3 is the correct option, correct? So you could do plus and minus. So 3 is okay. So 3 is the right option. This is z. I'm sorry. We have to find y component of A. So y component is what? Y component is 2 times z, which is 2 times 3, which is 6. So the option is D, not that. Correct? So I hope that works. Good, I read it at the last minute. Question number 13 here is, describe the octants in which the point -2, 1, and 3 is located. So let's look into this. We're talking about a point which is in R3. The location is -2. So when it is -2, you're going back. Do you see that? So that is your -2 position. 1, that means you're coming here and then going top, correct? So that gives you the position. So this -2 means back. And this 1 means right. And 3 means top. So that is the octant's position. So let's go back, right, top, which is option B. Perfect. Next question here is, determine the angle that this vector makes with the x-axis. So with the x-axis, we are looking for cos of alpha, which should be the x component 2 divided by its magnitude, right? So which is 2 square plus 1 square plus 4 square, or alpha is equals to cos inverse of all this, which is 2 over what is this? 4 plus 1, 5, and 16, which is 21 square root. Is it okay? So let's figure this out. So we do shift cos inverse 2 divided by square root of 21 equals to 64.12 degrees. Okay, so we have option B as the right option for this question. Now here is the last question, question number 15. It says, which of the following is coplanar with 1, 0, 0 and 0, 1, 1? 4 options are there. Now the best way here is we'll find the cross product. So we'll do cross product with these of 1, 0, 0 cross 0, 1, 1, correct? So let me do it in a different way. We do I, J, K, 1, 0, 0, 0, 1, 1. So we get I. So this is 0 minus J. 1 minus 0 plus K. 1 minus 0, correct? So 1 minus 0. So that means this is 0. So we get 0 I. And here we get minus J. And here we get plus K. So that is the value which we get, right? So we have 1, 0, 0, 0, 1, 1. Now with these values, we'll do dot product. So let's do dot product with all of them in turn and see which one gives you the right answer. So let's do the dot product with 0 minus 1, 1 dot. Let's do it with 2, 1 minus 1. What do we get? So this is 0 plus, and that gives you minus 1, and this gives you minus 1. So that is not equal to 0. Let's do it 3 minus 1. So we have 0 minus 1, 1 dot 3 minus 1 minus 1. So that is 0. And now here we get minus and minus is plus 1, and minus 1 plus 1 is minus 1. This is equal to 0. So option B is the right option, right? So with this, we come to an end of our multiple choice questions. I hope you have understood the strategy in the last question. We did the cross product and then the dot product, right? So basically scalar triple product equal to 0 means coplanar. Correct. So I hope you have understood most of the concepts of R3. We have learned about how the R3 is, what are octants, how to place your vectors, and how to do few operations in 3D space. Now we'll take a few application questions on vectors and then move on to lines and planes. I hope this exercise helps you. Feel free to write your comments and suggestions. If you like and subscribe my videos, that'd be great. Thank you and all the best.